Okay, so today we're going to talk about lab equipment, what it looks like, what it's called, how to use it, all that good stuff. If you are a in-person student, this should be day 2, lesson 1. And if you are online, this should be your day 3 assignment. All right, so we're just going to go through, you'll see a picture, I'll give you the name, and we'll talk about when and how you should use the equipment. So the first one we're going to talk about are beakers. You guys have probably all seen them before. We use them to hold chemicals while we're doing an experiment. We don't really use them to measure anything because they're not very accurate. They have these marks on the side, but those are kind of just there as a guideline. You wouldn't trust them to actually measure anything out because they can be pretty imprecise. So we will use them to do experiments in and mix things together in, but not to measure. They come in all kinds of different sizes, from little tiny 50 milliliter ones up to big old 1 liter ones, and we'll use all of them at one point or another. This is a graduated cylinder. This is what we will use to measure things in. It has markings on the side that are very accurate, very precise. So if we ever need a specific amount of a liquid, you'll go get a graduated cylinder. When you are measuring with them, you want to make sure that you're looking at it at eye level. You don't want to be looking up at it or looking down. You want to make sure you're straight on with it. So if you need to crouch down or bend over or whatever to get a good look at it from the right level and make sure you're accurate, then that's what you need to do. They come in a bunch of different sizes as well, from little tiny 10 milliliter ones all the way up to the big plastic 250 milliliter ones. Just depends on how much you have to measure out. All right, the next we have our 3 types of flask. We've got our Erlenmeyer flask first. The funny name is based off of the guy who came up with it. They're this kind of cone shape with the little narrow neck on the top. And the useful part of these is that they're good for mixing chemicals in, because you can kind of grab it by the neck and swirl it around without risking splashing or spilling. And that narrow neck also lets you put a stopper in it and plug it up if you want to capture any gas that is produced. The next is the Florence flask. These ones have the round bulb-shaped bottom, and they're really good for boiling stuff in. So if you put this on a ring stand and put it over a flame, a Bunsen burner, the stuff inside of it will boil really quickly because the bulb shape makes the heat transfer through it very well. And again, you can see it also has that narrow neck, so we can put a stopper in there or connect it to other glassware to collect any gases that are produced by the reaction. And then here we have the volumetric flask. You can see it has one line right here. That line is a very precise measurement. This one looks like it's 50 milliliters or maybe 150. I can't really tell because of the glare. But they are good for measuring that one specific volume, and that's pretty much it. So if you make like standard solutions over and over, where like I know I'm going to want to make this much of this one acid solution and I need a certain amount of the stock, then these are useful for that because they can measure very precisely that one amount. Other than that, you probably won't use them. And then here are the stoppers. They're called rubber stoppers. You can see how they would fit into the neck of the Florence flask or the Erlenmeyer flask. And then these little holes in them are where we could insert other kind of tubing or glassware that could stick up out of them and lead to maybe a distillation chamber or something like that, where we could collect products from the experiment. Or you can even put a thermometer in there to measure temperature, anything like that. All right here we have a test tube rack with the test tubes in it. Test tubes are good for when you want to do a lot of very small experiments side by side and compare and contrast them. So they're also good for holding different chemicals in them as storage while you're experimenting. That way you don't have to have a whole beaker full. You can measure it out into a test tube and have just that one little bit ready for you to use when you get to that step of your experiment. All right, you're never going to measure using them because one, they don't have any marks on them, and if they did, they wouldn't be that accurate. One thing to worry about with your test tubes is that because they're long and skinny and they have this narrow opening, if any gas is produced in them, it can sometimes cause what's inside the test tube to come shooting out of it very quickly. So we always want to make sure that we're not pointing them directly at ourselves or looking right down into them or anything like that. You want to make sure they're always pointed away from your face. And if you're supposed to get a sense of smell from your reaction, you don't hold it right up to your nose, you waft it in, right? Use your hand and wave it over the top to bring the air towards you. That way you can smell it without putting your face directly over the test tube. All right, here we have a burette and a burette clamp. These work with the ring stand that we'll talk about later, but a burette is useful for pouring out a very specific amount of a liquid a little bit at a time, right? So you'll fill up this long glass tube, that's the burette, and you can kind of see in the picture it has little marks on it going down the side. Those are very accurate markings. Sorry if you guys can hear my dog in the background. I'm recording from home, so it's just something that might come up from time to time. And then this little nozzle down at the bottom, if you turn this 90 degrees, it'll open up the flow and water will start flowing out, and you read it from top down to bottom. As it flows out, you can measure how much is coming out of it. All right. This is the ring stand that I've mentioned a couple of times. The ring stand is the base and this long pole. Together they're called the ring stand. And then the ring clamps are these that go on it. All right, and these are useful for all kinds of things. You can hold stuff over a Bunsen burner. You can hold your burette like we showed here to drip stuff out of it. You've got your burette clamp. You can also use this to hold a test tube if you want to hold a test tube over a flame or anything like that. So the ring stand we're going to be using a lot, and it's very, very useful. All right, here we've got test tube brushes. Pretty self-explanatory. They're used to clean test tubes. They're long and skinny, so you put them in there, swirl them around, and it cleans out the inside of the test tube. And this is a test tube holder. So you can see here, it kind of looks like a miniature version of like barbecue tongs or salad tongs. You pinch together these two little ring parts, and it opens up this section here, and you put that around the test tube, and then when you release it, it clamps back down. So if you have heated up a test tube, you always want to use these. That way you're not grabbing hot glass with your fingers and you could potentially burn yourself. And then, if you do grab hot glass and burn yourself, your instinct is to drop it. And then you've got hot broken glass and whatever was inside of it that could potentially be dangerous as well. So anytime we've heated up glassware, we always want to make sure we're using test tube holders or other types of tongs to pick it up. That way we don't have to worry about that kind of stuff. All right, here we've got our thermometer. You guys have probably all seen a thermometer before. One thing we do have to worry about with the ones in our lab is that they are very fragile, and they're not cheap either. So when we're using the thermometers, please be careful with them. I don't want to have to replace them all. All right, they don't have mercury in them anymore. They're all alcohol-based. So if they do break, it's not a huge health hazard or anything. It's just inconvenient, right? When you are using your thermometer, everything we do in here, we're going to want to use metric, so that is Celsius, not Fahrenheit. It's just how things are in science, right? It's the more standardized version. All right, this is your hot plate. Ours don't look exactly like this, but they're pretty similar. You'd put your beaker or your flask or whatever you're heating on top of here if you don't want to use a Bunsen burner and an open flame. And then you've got two knobs here. One of them is the heat, so it'll control how hot it gets, and the other one is for a stirrer. So we have little magnetic rods that we put inside the beaker, and if you turn the stirring thing on, it'll make that little magnet spin around and around and around and stir up your solution, so you don't have to sit there and stir it yourself. And then your other source of heat that we're going to use is the Bunsen burner. This right here is where the tube that goes to the gas attaches. So it'll be a little rubber tube that slides over this prong here. And then you've got right down here, you can adjust this to control how much oxygen is let in. And that combined with how much gas you're using from the gas knob on the table will control the height and the heat of your flame. All right, so the main reason you would use a Bunsen burner over a hot plate is if you wanted to heat something up really quickly, or if you wanted it to get hotter than 400 degrees Celsius, which is generally about the max that the hot plates can get to. Obviously, if we're using flammable stuff, or stuff that makes flammable fumes when it reacts, we don't want to use a Bunsen burner because that's an open flame, and that could be pretty dangerous. Alright, the rubber tubing, the main thing we use this for is connecting that Bunsen burner to the gas valve. So it would slide over this prong here, and then over a similar shaped one on the gas, and that's about it. Alright, the wire mesh or gauze. This we generally use with the ring stand. So if you've got your Bunsen burner sitting on the base of the ring stand, and you've got one of those circular clamps attached to it, you can put this wire mesh to sit on top of the ring, and the Bunsen burner flame, when it hits this wire mesh, it will spread the heat out and keep it from being focused in such a small area. What that does is it stops glass from cracking or breaking when there is too much of a difference in heat between one part of it and another one. So this we use just mainly as a safety precaution. This is the clay triangle. It kind of does the same thing. You put it over the ring, and this little clay bits here will absorb the heat and spread it out, and it also will keep things hotter longer once they get heated up, because these clay ceramic pieces will hold on to that heat and stay hot for a long time. You can turn off the Bunsen burner, turn the gas off, and not have to worry about it cooling off so quickly. This here is what's called a crucible, and the lid for it is called a cover. So this is if we want to heat up a solid, or generally a solid. We'll put it inside here and cover it, and that prevents it from being exposed directly to the flame. And it also, if you have the lid on this, it can build up a lot of heat inside of there, because this is ceramic and it conducts, or it holds onto the heat really well. If you leave the flame on, it keeps getting hotter and hotter and hotter inside that crucible, and it can get hotter than the heat of the actual flame itself. So when we're trying to melt down metals and stuff like that, generally we'll use a little crucible like this. And then these are called crucible tongs, which is what we're going to use every time we carry a crucible. Anytime you heat up glassware, like I was saying earlier, you want to use the proper tongs to hold it. That way you don't try and grab it yourself and burn yourself. Because just by looking at it, there's no way you can tell a hot piece of glassware from a cold one strictly by looking at it. They look the same, right? Because we don't get them glowing hot, but they're still hot enough to definitely burn you. So always use your tongs when you're working with glassware that's been heated. All right, and here are beaker tongs. So the main difference here, if you look at the crucible tongs, they've got this little upturned portion at the end. That's what you can use to grab the lid of the crucible and pick it up and take it off. And then the beaker tongs don't have that, but they have this non-slip rubber port on the tongs that helps it hold on to the glass of the beaker. Generally, we don't want to use the beaker tongs on the crucibles because the crucibles get much, much hotter, and it will melt this rubber part. And if we use the crucible tongs on the beaker, one, they're not usually big enough, and two, the metal directly on the glass can sometimes scratch it or break it or cause other kinds of problems. So make sure you're using the right type of tong. Alright, we've got our mortar and pestle. This is when we want to grind something into a powder. So if you've got big chunks of something and you want to make it into powder or smaller chunks, you put it in the bowl, which is the mortar, and you grind it around with this stick, which is the pestle. Alright, here is your scupula. The ones we have don't have these handles on them, but they look generally the same on this part. It's just a curved bit of metal with a little pointy end, basically. And this is what we use to scoop up powders. So anytime I tell you to come up to the front and collect, so many grams of a powder, you're going to be using a scupula to do it. All right, it doesn't have any measurement marks on it, so anytime you're using one of these and want to get a certain amount of something, you have to use it in combination with a scale or a balance or something like that to make sure you're getting the right amount. All right, and these are stirring rods. So if we're not using a hot plate with an automatic magnetic stirrer, you can use these little glass rods to stir whatever kind of reaction we're doing. And I mean, they're just glass rods. So you do want to be a little bit careful with them because they are kind of fragile, but there's not that much to them. This is what's called a striker. Inside here is a piece of steel that has all kinds of bumps and ridges on it. And then on the end of one of these arms is a piece of flint. So when you push the arm or push the flint across the steel by squeezing these two arms together, it makes a bunch of sparks. We can use this to ignite a Bunsen burner. You guys might have used them in welding too, if you guys are welding kids, to ignite your torches. One thing is that the flint does wear down over time when you're using it. So a lot of the ones we have in here don't have very good flints in them. So please do not use them and strike them when we're not actually lighting anything, because it's just a waste. And it means I have to go back and buy more flint and replace the flint in them. All right, these that look like big glass contact lenses are what are called watch glasses. If we ever have chemical reactions that we want to observe closely, we'll put them in here. A lot of times, if we do something that involves crystals growing, we'll put them in the watch glass and leave them. That way we can see the crystals form. We can kind of look underneath and from the side and from the top and all kinds of different angles and get a good view of the reactions occurring. All right, and this is an evaporating dish. This is one that you would put over a Bunsen burner to evaporate away liquid so we can collect the powder that would be left over. It looks a lot like the mortar from the mortar and pestle if we go back. The main difference is the evaporating dishes are usually much smaller and thinner walled than the mortar. Alright, and then we have a meter stick. You guys have all seen one before. You use them to measure the length of something. I don't know how often we will use it in the chem lab, but if we do have to measure length, this is what you would use. And then a funnel. If you need to pour liquid from one substance to another and they don't have spouts on them like the graduated cylinders do, you can use a funnel to make sure you don't spill anything. And then these here are called wash bottles. So usually they will have special water in them called deionized water, which is decontaminated basically. It means it won't mess up any of your reactions if you use it to clean out your glassware. Right? So after you do a reaction and you've washed everything, you want to rinse it with the water from a wash bottle. That way we make sure it's nice and clean and ready for the next glass to use. Something that you use in every single lab are these goggles. Anytime we go in the lab, you have to be wearing your eye protection. It's a safety thing, right? No matter what we're doing, we want to make sure we keep our eyes safe. And anytime that we're using anything corrosive that could get on your skin and burn you or anything like that, I'll make sure that you guys are wearing the aprons as well. A lot of times we won't need them, but when we do, you've got to have them on just to make sure that, one, you don't want to ruin your clothes if the acid or whatever we're using spills on them, and two, it's a safety thing. You don't want to hurt yourself. All right, here we've got a digital balance. This is what we'll use most often to measure mass. They're typically pretty precise, so you've got to be careful not to lean on the table or anything like that while you're measuring, because it can affect what's on the readout here. And you want to make sure that you zero them before every time you use them. So this button here says on and zero. So if you walk up, you put your weighing boat on it, you push a 0, you wait for it to blank out at 0, and then you can add whatever you're trying to measure and figure out how much of it you need. This is the older version, the triple beam balance. I don't know if we even have any of these, but we do actually. We probably won't use them, but if we do, you use these 3 blocks here and how far away they are from the fulcrum point here to balance out whatever is on the weighing platform. We probably won't end up using these, but you need to know what they are and what they look like. All right, and then here we've got pipette, pump, and bulb. So the pipette is this long little narrow thing that looks almost like a burette. The main difference is the burette is for adding liquid to a reaction, and the pipette you can use to remove liquid from a bottle, measure it, and then add it. All right, so it's kind of an all-in-one type thing. So this here, the green thing, is the pump. This on the side of it is your wheel that you'll turn with your thumb. So if you're holding it in your hand, you can rotate that wheel with your thumb like that, and that will draw liquid up into the pipette, right? Because this goes on top of the pipette, and then as you turn the wheel, it draws liquid up, and then once you've got the right amount of it, you take it over to whatever you're trying to pump it in, to put it into, push this little lever, and all the liquid flows out. All right, and then the bulb is just another, we typically won't use these, we'll use the pumps, but the bulb is just another way of doing it. Instead of turning the wheel, you squeeze the bulb and let it suck up however much you need, and then take it over to wherever you're at, squeeze it again to squirt it out. All right, and then these little guys, the disposable ones, are called barrel pipettes. All right, so these, you might have heard them called eyedroppers or something like that before, but they're pretty simple. You squeeze the bulb on top, put it in the water or whatever liquid you're using, let it go, and it sucks up however much is in there. If we use the graduated ones, that means they will have markings along the side. And if we ever need to use very, very small quantities of a liquid, this is typically what we'll use because they can accurately measure really small amounts. So like tenths of a milliliter, right? And that is the last one. So your assignment for today is going to be to go into the next page in Canvas. There's a version of this PowerPoint that has had the names removed and replaced with empty text boxes, and they've all been shuffled around. I want you guys to go through, put the names back in there, and then resubmit it as your assignment. So I know you know what they're all called and what they're used for. All right?